All right, we left off last time looking at this chart of combining or comparing the average formant values for men and women. Women tend to have higher formant values than men. I want to make sure you understand kind of a subtle point about this, which is that there's actually two things going on here. So you often hear people say, or maybe think that, you're not going to hear them think, at least not in this world. But anyways, you often hear people say that women have higher voices than men or men have lower voices than women. That can mean one of two different things. So the acoustics of male and female vowels differ reliably along two different dimensions. One is what's going on at the sound source, i.e. the vocal folds themselves, and the other is what's going on with what's called the sound filter. In this case, what's happening with the vocal tract. So at the source, there's reliable differences between men and women here. So these are the vocal folds that are producing the periodic voicing for a speech sound, namely vowels in this case. But that is going to depend primarily on the length and the thickness of the vocal folds. So men tend to have longer and thicker vocal folds. That leads to lower average F0. Women tend to have shorter and thinner vocal folds, and that will give them higher average F0. So, and that you can, sort of tweak as a speaker, whether you're a woman or a man. You can produce higher F0 or lower F0. So there's a given range that you can work with there. But on average, women will be higher than men. There's a similar but difference in what's going on with the sound filter, which depends on the length of the vocal tract, which you have, generally speaking, less control over than you do with the length and thickness of your vocal folds, but you still have some. So men tend to have longer vocal tracts. That gives them lower formant frequencies because the resonant frequencies are just lower when you have a longer vocal tract, right? Women have shorter vocal tracts, and therefore they have higher formant frequencies. So saying that women have a higher voice than men can mean two different things. It can mean that they have higher average F0, or it can mean that they have higher formant frequencies. Okay, so it's kind of easier to tease these two dimensions apart when you hear them in mismatched situations. So I'm going to give you some prototypical male and female voices, and then show you what happens when you kind of mix and match the different properties. So a prototypical male voice that I'll use is Andre the Giant. Andre the Giant, for those of you who might not know, was a very large man who was a star professional wrestler for many years, especially when I was growing up. He was one of my favorites when I was a kid. That phase is gone, but I still love Andre the Giant because he was cool and funny, and he was very large, which gives us some very good examples for this demo. But Andre the Giant, he was actually born with a condition called acromegaly, which means that your pituitary gland won't shut off the production of human growth hormone. So instead of being like a normal person where you stop growing sometime in your teenage years, you just keep growing. So they have to fix that, I believe, through surgery. And at any rate, they weren't able to stop it in Andre until he became very big. And so he had, basically very large vocal folds and very large vocal tract as well. So this may not be prototypical so much as it is sort of an extreme of very low F0 and very low formant frequencies. So these are a couple clips that hopefully you will recognize.
How long do we have to wait before we know the record?
Your guess is as good as mine. I'll beat you to pot. I'll take you both together.
I guess not very long.
All right, and here's another one.
Here we go. I saw the Francis table, and there they were, 4 white horses. And I thought, there are 4 of us. If we ever find a lady. Hello, lady.
Okay, cool. So when I first started teaching this class, I had this example of what was a prototypical female voice where you'd expect high F0 and high formant frequencies. Goldie Hawn is the example that I used to use. When she first became famous in the 60s, she used to play kind of a ditzy character on the show Laugh-In, which, again, in my teenage years is something I found entertaining. I can give you a sample of that.
There are 4 time zones in the United States. For instance, if you're having lunch in Chicago, it's breakfast time in California. Of course, if you're in Chicago, you wouldn't feel like breakfast if you're from California because you just had lunch. However, those living in New York, it's dinner time while we're still eating lunch here in California, which means the time is totally different as in the menu.
All right, so that sort of thing was entertaining in the 60s. who knows why. But in a more modern era, some of my students, my Canadian students, apprised me of the existence of a different TV character that I did not know about until I moved here. Maybe you're familiar with this person. She was on her character's name was Sugar. She was on a program called YTV. This is a screen cap that I found on the internet of her, but she sounds like this. It's definitely more extreme than Goldie's voice.
Total entertainment report. Okay, big things happening on YTV next week. You cannot miss it. Okay,
all right, we're not going to listen to however much of that, but it gives you a sense of what's going on when you have really high F0 and really high formant frequencies. So the interesting thing that happens is what happens when you get these mismatched. So sometimes you can have low F0, high formant frequencies, or sometimes you can have low formant frequencies and high F0. These things are dependent not specifically on gender or sex, but just the physics of the situation. So if you have long vocal folds, they will vibrate at a low frequency. If you have a long vocal tract, it will resonate at a low frequency. It doesn't really matter if it comes from a man or a woman. So when we get mismatches, we get interesting voices. And the first case I'll give you is a high F0 combined with a low formant frequencies. And that's what we hear in Julia Child's voice, who is, again, a TV personality from back in the day. She used to be on public television in the States, and she would teach people how to cook back before there was entire channels devoted to learning how to make meals or food or whatever. I'm not really that interested in that part of it. I will tell you that Julia Child was 6'2", which kind of gives you tends to give you a longer vocal tract than you would have otherwise, but she still had a high F0 in spite of that. So that gives her a very distinctive sounding voice.
Now, you can tell when they're ready by poking them with your finger. And if it's resilient, they're done. If it's still squashy, like the raw breast, it isn't done. And if it's hard, it is... it's overdone, which is too bad.
Okay, like I said, so Julia Child was a woman who just happened to be pretty tall. But again, these mismatches don't depend on what sex or gender you are. So I heard an example from Calgary of the same sort of combination from a guy who is a DJ on the radio on CKUA. I don't know if he still works for them. His name is Roy Forbes. He looks like this. This is what he sounds like.
Well, I don't know much about the Basin Street Boys, but that was a fine little number about essential utensils. I need a knife, fork, and a spoon from a 1946 exclusive 78.
All right. These are distinctive voices and may help you work in public broadcasting, I guess, because you sound more distinctive than you would otherwise. The opposite sort of mismatch is where you'd have a low F0 and high formants. The classic example of that is the guy who voiced the character Popeye. And in case you've never seen Popeye, that's what he looks like. This is also kind of loud, so I'll turn it down, but this is what it sounds like.
Come on, Olive. We gotta save little women and children from bandits. I'll get you out of this desert some way.
All right. I want to take a look at this. I think I'll pause the video for now to keep this video relatively short, but we'll make some measurements of these different F0 and formant values for these different speakers, and we'll see how they match up with each other.